Hi everyone, and welcome to our channel. Today we'll be discussing the breadboard and how it can be used to help develop your future projects. Once you've become familiar with the breadboard and its components, you'll come to learn that breadboards are essential to completing your circuits. Breadboards are great for prototyping because they can house simple to complex circuits and require absolutely no soldering. When you picture a breadboard, you might be thinking of a wooden board used to cut your bread on. Years ago, when electronics were big and bulky, circuits were built by connecting nails or thumbtacks on a breadboard with copper wire. Since then, electronics have gotten a lot smaller and there are better ways to connect circuits. However, we still use the term breadboard today. The best way to explain how a breadboard works is to break it down into three major areas: the terminal strips, the power rails, and the dip supports. The terminal strips, or the horizontal connections, located here, have metal strips to make components electrically connected to anything else in that row. You'll also notice that each horizontal row is separated by a ravine in the middle of the breadboard. The ravine isolates both sides of a given row from one another, and they are not electrically connected. We'll discuss the purpose later on, but for now, just know that each side of a row is disconnected from the other. The power rails, or the vertical connections located here, are metal strips that run parallel to each other and give you access to power. Usually they are labeled with a positive sign and a negative sign with a red and black strip to indicate the positive and negative side. It is important to remember that the power rails on either side are not connected, so if you want the same power source on both sides, you will need to connect the two sides. The dip support located here stands for dual inline package and is often referred to as the ravine. The ravine isolates each side of the breadboard and serves to connect integrated circuits known as ICs or other multi-pin sensors to fit onto the breadboard. Since each leg on the IC is unique, we don't want both sides to be connected to each other because it could interfere with the functionality of the leg on the opposite side. This will become useful when we work with push buttons, motor drivers, in later tutorials. Thank you for watching this video. Please let us know if you have any questions in the comment section below, and be sure to check out our other videos on our First Nations Mesa channel.